Some of the students who struggle most in physics are the smartest ones in the room. They understand the lectures, they follow the examples, they've succeeded in other hard classes. Physics still doesn't cooperate. That's not bad luck, and it's not a contradiction. I'm the physics sensei, PhD in physics, black belt karate, and 30 years teaching college students just like you. My job is simple: to train you the right way so intelligence finally translates into performance. Today, I'm going to show you why smart students still struggle in physics and what's actually getting in their way. You know that if nothing changes, here's what happens: you work harder, you doubt yourself, and you start assuming physics just isn't your thing. That frustration doesn't come from difficulty, it comes from misalignment. So here's the truth: physics doesn't reward intelligence the way other classes do. It rewards structure, execution, and trained decision making under uncertainty. So in this video, we're going to break down 5 reasons smart students still struggle in physics. The first problem smart students face is not technical, it's identity. When physics doesn't click immediately, it feels personal. Here's what's actually happening: you're turning a skill problem into an identity problem. Physics performance comes from actions: how you start problems, how you practice, how you correct mistakes. But when you label yourself, you stop looking at actions. Metaphysics sounds like a trait, something fixed, something permanent. But physics, it's an identity, it's a trainable skill. No one is born knowing how to model forces, interpret motion, or choose equations. Those are learned behaviors. This label creates a hidden problem. When something goes wrong, you don't ask, "What did I do wrong?" You think, "This just isn't for me." So nothing gets corrected. That's why effort doesn't translate into results. You study more, you try harder, but you never fix the specific action that failed. The identity label blocks diagnosis. Strong students don't talk about who they are, they talk about what they did. They say, "I rushed the setup, I guessed instead of reasoning, I didn't check the situation." Those are fixable things. The moment you stop saying, "I'm bad at physics," and start saying, "This action didn't work," everything changes. Now you have leverage. You don't need confidence, you need accuracy. Identify the action, correct the action, repeat. That's how performance grows. If physics feels personal right now, it's because you made it personal. Take identity out of it, put training back in. So here's how you train this. First, take it easy. The next time you miss a physics problem, write this sentence: "I missed this because I didn't," and fill in one specific thing. For example, "I didn't draw the diagram." Now, this next level, pick one wrong problem from homework or from a quiz. Circle the first step you got wrong. Ignore the rest of the solution, just the action you fix. Then the challenging part. For your next 5 study sessions, do this rule. You're not allowed to say, "I'm bad at physics." Every time you feel stuck, you might say, "The step I need to fix is," and say it out loud. That is how identity turns into training. Smart students are used to feeling competent. When physics creates friction, they don't quit, but they do avoid the discomfort by staying in familiar territory. Here's what's actually happening: you're training under uncertainty. In physics, the path is rarely obvious at the start. You don't know the equation yet. You don't know the direction yet. You don't know if you're right. That feeling isn't failure, it's just the training zone. Most students try to eliminate discomfort. They look for work examples, they reread notes, they wait for certainty. That feels better, but it stops learning. Comfort means recognition, and recognition means familiarity, and familiarity means you're not making decisions, and decisions are the skill physics tests. This is why practice feels harder than lecture. In lecture, the structure is provided, the uncertainty is removed. In practice, you must choose, you must commit, you must risk being wrong. That discomfort is the point. If learning feels smooth all the time, you're not training the right thing. You're staying in safe territory. And physics lives outside that zone. Strong students don't avoid discomfort, they expect it. They know that confusion means I'm about to learn something. They don't rush to erase it, they work inside it. The mistake is thinking discomfort means incompetence. It doesn't. It means your brain is being asked to decide without a script. That's exactly what exams demand. If physics feels uncomfortable right now, don't retreat. Don't soften the work. Lean in. Here's how you train this. Pick one physics problem before doing anything else. Sit with it for 10 seconds. No writing, no equations, just read it and wait. When you start a problem, write one line at the top. This problem is about. For example, this problem is about an object slowing down. Do this before any math. Then challenge yourself. Once per study session, solve one problem without looking at notes until you decide what type of situation it is. You are allowed to be wrong. You are not allowed to look early. That discomfort you feel there is exactly the skill being trained. That avoidance shows up right at the beginning of problems. Smart students try to move fast instead of building structure. Here's what's actually happening. When you read the first line, your brain tries to solve immediately. You scan for numbers, you hunt for formulas, you ask, which equation is this? That's the mistake. Physics problems don't start with equations, they start with situations. And when you skip that step, your brain stalls. That freeze is not confusion, it's a missing structure. Your brain is waiting for one thing you never give it. What is happening here physically? Until that question is answered, nothing else works. So the system locks up. Homework feels easier because you just saw a similar problem. You know which chapter you're in, and you expect the formula. On exams, all of that disappears. Now, we have to decide what kind of situation is this? What system am I modeling? What matters and what doesn't? If you never train that skill, the exam exposes it immediately. That's why the freeze happens on the first line. The first line of a physics problem is not information, it's a description of reality. If you treat it like a formula trigger, you stall. If you treat it like a situation to interpret, you move forward. That difference decides everything. Strong students pause. They don't rush to solve. They ask, what is happening here in this particular problem? What objects are involved in this situation? What is changing here? So I need to understand what's happening. They build the picture first, and the equations comes after that. If you freeze on the first line, stop blaming pressure, stop blaming the math. You're not failing physics, you're just skipping the setup. So fix how you begin, and the rest of the problem starts to cooperate. Understanding an idea is not the same as executing it. Physics grades execution, not understanding. Here's what's actually happening. Understanding feels good, but understanding is passive. You recognize the ideas, you agree with the explanations, and you say, yeah, that makes sense. But none of that, it's performance. Physics on an exam is not recognition, it's execution. You have to decide what applies here, what doesn't, what matters first, and if you never train those decisions, your understanding collapses. That is why class feels easy and exams feels brutal. In class, the path is shown to you. The steps are guided. The thinking is done out loud. On an exam, you are alone with the situation. No hints, no structure, and if you only practice understanding, you weren't training performance. Understanding answers the question, do I recognize this? Performance answers a different question. Can I act when nothing is obvious? Those are not the same skill. This is why students say, I knew this stuff, but can't start the problem. They train familiarity, not execution. Strong students do something different. They practice deciding, they practice choosing an approach, they practice starting without guidance, they train the uncomfortable part. Understanding feels safe, performance feels uncertain. But physics lives in uncertainty. If you never train there, exams expose it immediately. If your understanding disappears under pressure, stop blaming stress, stop blaming memory. You didn't fail because you didn't understand. You failed because you didn't train performance. Fix what you train, and results start to change. And finally, familiarity pretends to be mastery. Things feel recognizable, so feedback stops. Here's what's actually happening. You're confusing recognition with understanding. You recognize formulas, you recognize diagrams, you recognize work examples. Recognition feels like understanding, but it isn't. Recognition answers this question: have I seen this before? Understanding answers a different one: can I decide what to do next? Most students never test that second question. That is why studying feels good. You reread notes, you watch videos, you follow solutions. Everything looks familiar, but familiarity doesn't require thinking, it requires exposure. On exams, familiarity disappears. The problems phrased differently, the diagrams look new, the numbers don't match your notes. Now recognition fails and nothing replaces it because the decision making was never trained. That is why students say, I understood this yesterday but freeze today. They didn't lose understanding, they never build it. Strong students test understanding differently. They close the notes, they look at a new problem, and they ask, what does this situation ask me to do? If they can't answer that, they don't move on. They diagnose the gap immediately. Understanding isn't feeling comfortable, it's being able to act without guidance. If you can't start without help, you don't understand yet. That's not failure, that is feedback. Stop trusting familiarity. Start testing decisions. That's how real understanding is built. Your intelligence is not the problem, but is not the solution either. Physics requires skills that must be trained deliberately, and those skills don't automatically come with being smart. So let's recap. Why smart students struggle? 1. Identity turns difficulty into self judgment. 2. Discomfort is avoided instead of trained. 3. Speed replaces structure at the start. 4. understanding is mistaken by performance. 5. Familiarity blocks real feedback. Physics doesn't care how smart you are, it cares how well you are trained. Once you stop protecting your intelligence and start training execution, everything changes. Train the basics, build your foundation, and let consistency become your advantage. And if you need more help, the dojo is ready when you are. I'll see you inside.